This is the first of 4 parts in the lecture on the analysis of bonds with embedded options. In this part, we look at the arbitrage-free value of a bond and the static spread. Now, we've talked about the arbitrage-free value of a bond quite a bit ago, and when we talked about the proper valuation of a bond using the spot rate curve. Now, we're going to use that technique in order to come up with a yield spread for a bond, and this will enable us to look at how bonds are priced and then lead us into the discussion of bonds with embedded options. Usually when we look at a yield curve premium, we're looking at non-treasury bonds, comparing them with treasury bonds, and we come up with a yield premium by comparing the yield to maturity or the yield to call for the corporate bond with the same maturity treasury security. And there are 2 primary drawbacks to this. The first is that we don't consider the term structure of interest rates, and the steeper the term structure, the more important this becomes. And in the case of a callable or puttable bond, the possibility of interest rates changing then introduces the idea that cash flows may be altered for the bond in the future. So what we need to do is somehow incorporate interest rate volatility into our valuation process. So that's what we're talking about in this whole segment, and we're going to focus on the static spread in this particular lecture. If we look at 2 bonds, a treasury bond and a corporate, both have the same coupon, both have the same maturity, so an 8.8% coupon and a 25-year maturity. If we look at their prices and look at their yield to maturities, we would describe the yield spread as being 109 basis points. But this is done simply by calculating the yield to maturity for each bond and then comparing these yields. We haven't considered the term structure of interest in all of this, and we haven't considered that the corporate bond may be callable, puttable, or even convertible, which of course will be the next set of lectures. So what we're going to do is provide an alternative to simply subtracting the yields, and this is going to involve using the spot rate curve. If we were not using a spot rate curve, we simply compare the yields, we really do not have an adequate comparison because the timing of the cash flows may be different, and this would lead to different interpretations of the yield. So what we want to do is make some adjustments here. What we're going to do is compare the corporate bond with the treasury. But what we're going to do instead of simply comparing the yields to maturity is we're going to first look at the treasuries as a portfolio of zero coupon bonds. In other words, we're going to use the spot rate curve. And so we're going to use the spot rate curve to help value the non-treasury bond. What we're doing here is using the spot rate curve, and then we're going to assume a spread. We're going to assume a spread and see if this provides the value of the corporate bond. If we first assume that the corporate bond is riskless, then we should be able to use the Treasury spot rate curve to value this bond. If the corporate bond is not riskless, as is most of the case, it's not riskless, what we want to do is say, use the spot rate curve, but add basis points to the yield at each cash flow timing at the same amount, and this is called the static spread. Now the reason it's called the static spread is we're talking about the same number of basis points added to each position on the spot rate curve. So we're saying that this spread does not change over time, hence the word static in the description. So as you can tell, we're going to start with the spot rate curve, and we're going to try to figure out how many basis points to add to that spot rate curve so we can value the corporate bond. Now this is basically the structure. If you have a corporate bond and let's say it's riskless, okay, that's not realistic, but at least a starting point for discussion here. So let's say we have a 25-year bond, 8.8% coupon, so it's the same bond we looked at a moment ago, and we're going to use Treasury spot rate. So we've gone along and calculated the Treasury spot rate curve. So what we do is we have the 50 periods, that is one for every 6 months. We have the cash flow, 4.4 per period. We have the Treasury spot rate. We're going to have 50 of these. And then we calculate the present value of each cash flow. So if we take the cash flow of 4.4, what we want to do in the first case is discount it one period at 3.5%. That gives us the 4.2512. As another example, look at period 46. That's 46 6-month periods out in the future. We take the 4.4 and we divide it by the 1 plus 0.0505 to the 46 power. We get the 5.05% from taking the 10.1% and dividing it by 2. If this corporate bond was also riskless, then we expect its value to be the 96.6134. That is the sum of all the present values of the cash flows. So valuing, just using the Treasury spot rates, we can end up with the 96.6133. That would be the arbitrage-free price of the bond if it were risk-free. That is default risk-free. But because the corporate bonds are not default risk-free, then the value would be something less than the 96.6133. In other words, investors are going to demand a premium in terms of the yield for bearing risk. There's going to be some default risk, and they're going to demand a premium for this. So the value will be less than the 96.6133. The static spread is the amount of the premium, or the spread that we're going to add at each maturity. Now this is called a zero volatility spread, or a Z spread. What we're assuming is a particular term structure of interest, that is a spot rate curve. So we're making an assumption regarding a spot rate curve, what it will be in the future. So what we're doing is using that information and adding a certain premium to that spot rate curve. Remember, this premium is added to each spot rate. The 6-month rate, the 1 year, the 1.5, the 2 year. Now in terms of how we figure out the spread, what we're trying to do is figure out how many basis points we'd have to add to each of the spot rates along the spot rate curve, so that the present value of all the cash flows is equal to the bond's current price. So we know its current value, we know its cash flows, and what we're trying to solve for is how much we have to adjust the yield for. And that what we're going to do is we can use a trial and error, I'll show you in a moment, or we could use Excel solver. So we're going to show you that in just a moment. Now this would be a trial and error approach for this. Same bond information that we had before in the first 3 columns. What we're doing now is, instead of discounting at the Treasury spot rate, we're discounting at the Treasury spot rate plus a specific number of basis points. So in this column here where it says 100 BP, we're adding 100 basis points to, say, the 7%. And this is how we're going to get our discount rate. So we'd add 100 to the 7%, so we'd have an 8% rate. We're going to take the 4.4 cash flow in the first period, divide it by 1 plus half of that 8%, or in other words, 1 plus 0.04. And that should give us the 4.2308. We repeat that for each one of the cash flows. Add them up, we get the present value if there's a 100 basis point static spread, and that would be 88.5474. Now what we do in this trial and error is add different number of basis points and see what the present value is at the bottom. Now if the bond's value is 87.8029, then we know that the static spread is 110 basis points. Now using this trial and error method would be rather tedious if we have to do it very often, and so we are much better off if we use Excel, which we will do at the end here. Now just to give you an idea though, we'll talk about the importance of using a static spread instead of simply calculating a risk premium, if we will, in the traditional method, is that the bond is priced according to the static spread. That's how we believe it's priced. And the yield premium, just by simply taking the difference between the yield to maturities, will not be accurate because we're not taking into account the term structure of interest. Now, the difference between a traditional yield premium and the static spread really depends on the shape of the yield curve, and it depends on the maturity of the bond. And when you combine the two, for example, you have a sinking fund where you have retirement bonds, or in other words, early calls, or mortgage-backed securities that have prepayment. You combine that with a steep yield curve, and you have quite a difference between the traditional yield spread and the static spread. And that's why you will see the static spread used more often in describing and valuing mortgage-backed securities. Now using Excel, what you would do is you would set up the given information, say the coupon rate, the maturity, the current price. You would set up the appropriate number of periods, 6-month periods. You'd have a Treasury spot rate curve that you'd estimate. And then you would put in the formula for discount rate, which would be, discount rate is going to be the Treasury spot rate curve plus the static spread. You would also insert the cash flows. And then you would calculate the present value of the cash flows as being the cash flow divided by 1 plus half the discount rate in the first case. And the next period, 1 plus half the discount rate to the second power, and so on. And you'd have a summation of all these present values, in this case 95. Our goal is to solve for the static spread that causes the sum of present values to be equal to the current price. When they're equal, that means we've accurately estimated the static spread. And consider a problem. 5% coupon bond, 3 years to maturity, and a price of 96.49. So we've got a Treasury spot rate curve. We've got all that built in. And what we'd want to do is calculate or estimate the static spread. Now when we look at Excel, we have an example here. This is a spreadsheet. Now you have to use developer ribbon, so you add that if you don't have it already. You have to enable macros to have this run. But what you do is you input the coupon rate, maturity and the current price of the bond. Then you set up the present value calculation, as you can see here. And now this is set up to automatically run solver. It has a private macro behind it so that it'll run anytime you change the inputs. So if we were to change the inputs, say change this to 3 years, and 96.49, so let me just change that by a penny so you can see how this actually works. Anytime you change any element here, it will resolve and come up with a different static spread. So for that problem at hand, the static spread is 291.19. And all we've done here is let solver do the work of solving for the static spread. So the objective function is to have the difference in the sum of the present values and the current price to be equal to 0. So that's our objective function. And what we're changing, so by changing, what we're changing is the static spread values in here. So that's how we use solver to our benefit. Now, if the Treasury spot rate curve changes, if any of the other inputs change, you can see changing this just a little bit. Let's say the price goes to 98, and therefore the static spread will be 234, and so on. So you can see how a little bit this works. So this is your introduction to static spreads. Now, why do we have static spreads? Why do we worry about it? One, it gives us a bit more accurate yield premium than simply comparing yield to maturities. But also, this concept of a static spread is important in looking at premiums associated with embedded options. So it's one of those key ingredients we need in order to look at the valuation of callable bonds and puttable bonds and so on. So that's where we leave you today.